Assalamu warahmatullah. In this period, we will solve exercises about chapter 2. In the first exercise, answer by true or false and correct the false statement. The elements in periodic table are arranged in decreasing order of atomic number. If we return back to what discussed in previous period about the arrangement of element in periodic table, the element in periodic table are arranged in increasing order. It is a wrong statement. False. It is in increasing order. Columns of periodic table represent the number of valence electron. It is a correct statement. This is a definition of a column. Column, it is equal to the number of valence electron in outer energy level. It is a true statement. Third statement, an atom of atomic number Z equal to 5, its electrons are distributed in two energy levels. In order to distribute the electrons, we have 5 electrons. Since it has an atomic number Z equal to 5, electrons is equal to number of protons, then the electron configuration is K2L3. So these 5 electrons are distributed in two energy levels, so it is true statement. The sequence of energy level is KMLN. It is a wrong statement. False. The sequence of energy level in an atom is as following: K, L, M, then N. The last statement, there are two valence electrons for an atom having 14 electrons. 14 electrons. They are distributed in energy level K2. L8 we have 10 electrons and M4. So we have 4 valence electrons. 4 valence electrons. So the statement is false. Okay, let's continue in the second exercise. Choose the correct answer. The valence electrons are electron form. The definition of valence electron is that will first energy level or in all energy level represent all the electrons in all energy level or the outer energy level. Valence electron means the last. فإذا هي outer energy level. Electrons in an atom are distributed in 3 energy levels, so the atom is placed in row. Since there are 3 energy levels carrying electron, so it is in row 3. The outer energy level of lithium has 1 electron. Then it is placed in column 1, column 2, or column 11. As we talked in previous period, if we have 1 valence electron, then it is in column 1. The number of electrons in K2L8 M6 is equal to 16. We have 2, 8, 10 electron, and 6. The summation is equal to 16 electrons. The atomic number of an atom having 5 valence electron energy level is, and we have energy level L, and there are 5 electrons on L, so we have 2 energy level K and L, 5 electron on L. They are 5 valence. الفالence يعني last level L, so K will be saturated by 2 electrons. The total number of electrons in this element is 7 electrons. Since there are 7 electrons, then the atomic number is equal to 7. In exercise 3, potassium is a vital mineral that is necessary for the correct function of tissues needed for sending nerves impulses. Potassium helps muscle to contract and keep your heart functioning properly. Some of other animals that are found in human body are phosphorus, that plays a role in growth of cell, and fluorine, which strengthens our teeth. Given potassium has one valence electron and 4 occupied energy level. So is only one valence electron for potassium in part 1. We must determine the atomic number of potassium. We want to show that it is 19. One valence electron and 4 energy level. In order to show that has an atomic number, one valence electron and 1 electron in outer energy level. For energy level, we have K, L, M, and N. And the 1 electron in outer energy level, we have here 1. Then the other electron of the other energy level will be completed by K2 electrons. L is completed by 8, M is 8, and the last energy level is 1. The total sum of electrons, number of electrons in potassium is equal to 2 plus 8 plus 8 plus 1 is equal to 19. Since atom is neutral, and atom is neutral, this means number of electrons equal number of protons. Then we write the answer as following: number of electrons equal number of protons, so equal to the atomic number Z is equal to 19. So we prove that potassium has an atomic number 9. Then we justify the following as following: 1 valence electron mean 1 electron in outer energy level. For energy level mean it has K, L, M, N energy level and carrying 1 electron. So the previous energy level K is 2, L8 and M8 and N1. So the total number of electrons is equal to 19. Since the atom is a neutral, number of electrons equal number of protons, so the atomic number is 19. دايما بجاوب أنا بهالطريقة لأوصل للatomic number. هلا بالsecond part, in part 2, the number of neutrons exceed the number of electrons by 1. This means number of a neutron is N is equal to number of electrons plus 1. And since the number of electrons is equal to number of protons, then we can write it is N is equal to Z plus 1. Determine the composition. When you ask about the composition of atom means that we must find the number of protons, we must say how many neutrons and how many electrons. This meant by composition of atom, find the number of protons, the neutron and electron. Is the number of protons in part 1 is equal to 19. We prove this. Number of protons is equal to 19 here from part 1. Also number of electrons is equal to 19. To find the number of neutrons, the neutrons is equal to n, which is n equal to z plus 1. So n equal 19 plus 1 is equal to 20. So we find the composition of atom, the number of particles, proton, neutron, and electrons. Second part, deduce its atomic mass. To find the atomic mass, the term atomic mass mean equal mass number with unit U. To find the mass number A is determined by the relation Z plus N. نجمع Z with N protons and neutrons. Z is equal to 19 when N is equal to 20, so the mass number is 39. So atomic mass is equal to 39 unit U. Isn't to find the atomic mass, we find the atomic mass from the atomic mass is equal to the value of the mass number, same value as mass number, taken with a unit U. In some books they write unit AMU, atomic mass unit. Okay, A equal to Z plus N. We sum the number of protons and neutrons. For a fluorine atom, we have a given for a fluorine atom, nuclear charge is equal to 9 plus, and the charge of a proton is 1 plus. Deduce the atomic number. Then we use the relation or write the relation of the nuclear charge, the relative nuclear charge is equal to relative charges of protons. Okay, relative charge of the proton is equal number of proton times the charge of one proton equal to number of proton, this is 9 plus number of protons times 1 plus, divide by 1 plus, divide by 1 plus, so the atomic number is equal to 9. We deduce the atomic number of fluorine is equal to 9. Okay, let's continue. Part 3.2. Write the electron configuration and the lowest dot symbol. Since the atomic number is equal to 9, and we write in a neutral atom, in order to write electron configuration, we must find the number of electrons. In a neutral atom, number of electrons equal number of protons equal to the atomic number Z. So we have 9 electrons, so they are arranged in KL, K with 2, L with 7. To write the lowest dot symbol of fluorine, lowest dot symbol of fluorine depend on the valence electron. We have 7 valence electrons, so the lowest dot symbol of fluorine we have 1, 2, 3, 4, 5, 6, and 7. Also we can write it as the following 1, 2, 3, 4, 5, 6, and 7, or we can just write the electrons as 1, 2, 3, 4, 5, 6, and 7. We can rearrange these 7 electrons in any direction, and all the following symbols are correct. Specify its position in the periodic table. specify, we must explain how we find the position. Position mean row and column. Since the electron configuration is K2L7, it is in row 2. Since we have two energy levels carries electron, and column 17 since there are 7 electrons in outer energy level. So by the following we specify what is the position of fluorine in the periodic table, where its position in the periodic table is in row 2, since there are two energy level, K and L energy level. Column 17, we have 7 valence electron, so we have column 17, or it's found in column 17. Identify the number of electron in phosphorus. In this example or this exercise, phosphorus is in row 3 and column 17. Also identify, it need explanation. Isn't row 3 mean there are 3 energy levels, K, L and M. Column 15, this mean 5 electrons in outer energy level. The whole M. In the last energy level M, we have 5. To combine these two reasoning, we reach to K2, L8 and M5 as an electron configuration. The number of electrons in this element is equal to 8 plus 5 is equal to 15. We write the answer as following, by specifying what is row, what we can determine from the value of row, from the value of column, and then we add the total number of electrons in the different energy level. Calculate the relative charge of electron in phosphorus atom. In phosphorus atom, we have 15 electrons. The relation for the relative electronic charge is equal to number of electrons times relative charge of 1 electron. Is equal, number of electron is 15 and the charge of 1 electron is 1 minus, so the value of the relative charge is 15 minus. This is the value of electronic charge in phosphorus atom.